Okay. We're going to go through this ambiguous case worksheet. It says, look at the angle below. Draw inside AC so that you create triangle ABC. C can hit anywhere along the horizontal line so that ABC is not a right triangle. So don't drop it straight down. So I'm going to draw mine in. Apparently, I'm not going to draw mine at all. I'm going to draw mine inward like this. I'm going to call that C. So now I have a triangle, correct? Now look at the next thing. Now draw another triangle by connecting AC to another point along the horizontal line. AC must stay the same length. So you can make yourself like a little compass. Whoops. So mine would come about right. Oops, apparently not there. Okay, so this is another possible C. We could call it C prime if we wanted to. So now, watch real quick. I have just made, do you agree that AB is the same in both triangles? Do you agree that angle B is the same in both triangles? And do you agree that AC is the same length as AC in both triangles? So that's what it's saying right here. I have noticed that side AB and AC are congruent in both. This is congruent to this, and obviously that is congruent to itself. You with me? And this angle B is the same in both triangles. How many triangles are possible when given side, side, angle? 2. Here they are. Look at them again. Triangle number 1. Triangle number 2. Both having two equal sides and 1 equal angle. No, go ahead. Okay. So this is why side-side angle, or angle-side-side, doesn't prove triangles congruent. This is why you were not able to use this bad word to prove triangles congruent in geometry. Okay, don't worry about this right now. I want you to watch this that I have. This, Mr. McGann, because he's brilliant, made a geometry sketchpad situation. Okay, look right here. I have an angle that's given. It's 27 degrees. You see it here? Angle A. That's going to stay the same because I can't move this long line and I can't move C. I also know the length of C is 5 and I know the length of A is 4. Watch. Do you see that triangle? Or that triangle? Well, it's because if I were constructing this, that's how I would do it. Okay? Now watch what happens when I make A longer. I still get one triangle, but what happens to my second triangle? It doesn't work. So when is it that I don't get 2 triangles? When A, the side across from the given angle, is longer than the other given side. You don't want to remember that as much as here's what you do want to remember. When do you get 2 triangles? When the side across, and you're going to hear me talk about this as the swinging side. See why? And the swinging side is the side across from the given angle. You see it? So when the swinging side, or the side across from the given angle, is shorter than the other given side, I can get 2 triangles. That's what you have to look out for. is when the side across from the given angle is shorter than the other side. Now, every once in a while, you don't have 2. Let's do another shorter. That's shorter, but what's happened now? It's too short. It's so short I can't reach and I can't make a triangle. Does anybody remember from geometry the little rule about the sides of the triangles? Well, we can't say hypotenuse, we just say the third side, but you're right. Any 2 sides of a triangle have to add to be longer than the third side. Think about it. If I had a length of 10, and this was 4, and this was 3, they wouldn't meet, right? This one would have to at least be 5, and this one be 5.1 maybe.
What about 36 and 90?
Still, any 2 sides of a triangle, that's the degrees.
Oh.
We're not talking degrees. So no matter what, any 2 sides of a triangle have to be, when you add any 2 sides together, they have to be longer than the third side. And that's what would not happen in this case. Okay? So that's one. How are you going to know when that's the issue? It'll be this. Let me write it here so my recording friends can see it. Do you remember the warm-up that said this? What happened in your calculator? Error, because that's outside of the domain. What will happen when there's no triangle is you'll do your law of sine, and you'll end up with that. And you can't do it, and that's implying to you, after you double check and make sure you closed all your parentheses and did all your math right, there's no triangle. And usually there's another telltale sign, like angle 100 is across from the shortest side or something, where from the get-go you're like, that can't even work because that side is too short to be across from a big angle. So this scenario in which it's too short, it's pretty easy to detect. But if you don't detect it even before you start, your inverse sine is going to not work for you. Okay, and then there's one other scenario, and that is, let's see. I want to make a right angle right there. I need to go a little smaller than 27, don't I? That's pretty close. Let's go 24. There we go. So when it is a right triangle, then you'll only have one as well. And it'll produce itself as well. You'll get a 90-degree angle. Okay? And you'll try to do 2 triangles, and you'll end up with the exact same one both times. I don't have time to teach it twice. So you got to listen the first time. Okay, we got it? So let's do an example together, and let's see how this is going to work. Look on the back. Oh, I'm sorry. Look at the bottom of yours. You have case 1, case 2, case 3, and case 4. Look at case 2 is the main one you need to remember. Case 2 is when the side across from the given angle is shorter than the other given side. So you're looking for the side across from the given angle to be shorter than the other given side. So you can refer back to that little, to this geometry sketch pad on the bottom of those notes. Okay, as it is, let's go ahead and do, on the back, example 1, you're going to need to do it in your spiral. This is example 1. Now, this is one of those times where you need to write every single thing I do so that you have a good example for your notes to mimic when you get home. Okay, so given 2 sides of a triangle and with a non-included side, which is a not included angle, which is side-side angle, find all possible values for the other sides. Now listen up real quickly. all through this worksheet, it says find side C, find side Z. I don't want you to do that. I want you to solve the whole triangle. Find all the sides and all the angles. So you can scratch that part out. But since I'm adding that work to you, I'll let you scratch out 8, 9, and 10. You don't need to do 8, 9, and 10. I think 1 through 7 is enough. I think 1 through 7 will get you all the situations. And that's good enough. Practice all the situations once or twice. You don't need to do more than that. Okay, here we go. Example number 1. What do I know? I know side X is what? 4. I know side Y is, look at that. Let's go with 4. I know side Y is 5, and I know X is 27 degrees. Now, when you set this up, this is the situation, which is angle side side. Don't get that confused with this. Is that angle side side? That's side angle side. And that one's okay, right? That doesn't spell a bad word. So if you're set up like this, you're fine. You don't have two triangles. Angle, side angle side is not ambiguous. It will not give you two triangles. It's only when you have two sides and the angle across from it. Angle side side. Okay? Now, how would you want to solve this? If you just didn't know anything, homework last night, I gave you this question, what would you do? Law of sines, law of cosine? Why would you do law of sine? Because I have a side across from an angle given, and I can make a ratio, right? And I don't know about you, but I like law of sines better. Did y'all notice it's a little faster? So if I can do law of sines, I'm going for it. So since I can, how do you know when to do law of sines? When you have an angle across from a given side so you can make a ratio. Let's do it. Sine of 27 over 4 equals, Michael, you can do it. We only have 30 more minutes. Push through. Got to listen. When you're not confused on Monday, you'll be happy you listened. This is going to be online, though, because I have enough absences. I think I forgot to take roll again. Okay, y'all do that while y'all work on this. Oh, frozen. Hello. Okay. So here we go. 5 times sine 27 equals 4 sine y. And then you divide it by 4. And inverse sine, that is so weird. Do you see how that just was randomly read by itself? Oh, well, my red pen doesn't work, though. No idea. Oh, well. So it's sine inverse of all of that. And what did you get? What does y equal? 34.575. You agree? Okay. Now, 34.575. Right now, we have to keep in our brain, I might have two triangles, or I probably do have two triangles. So remember, just like the sine of 30, also 150, they're supplementary, right? 30 and 150 are supplementary. We need to find the supplement to this, and that'll give us the other place that sine is this same value. So everybody do this. This is your first angle. Okay, how do we get our second angle? We do 180 minus the first. Okay, so we have two y angles. What is 180 minus 34? Correct? So what I want you to do when you do these is box that one out. That's one triangle. Make another box. X, Y, Z, and then X. Now this Y is, what did we just say? 145, 425. That's how easy this is to find that second angle. Okay? Now what could we do? To finish each one, we can now find a third angle in each block, can't we? Everybody do that 180 minus. Actually, if that's in your calculator right now, you might as well do 180 minus the last answer minus 27. Work with what's in your calculator. 180 minus last answer minus 27. What do we get? I need somebody to second that. 7.575. Okay, let's come over here. 180 minus 27 minus 34.575 for our first triangle, and what do we get? What? Yeah. These are not supplementary. Every year I have somebody try to do 180 minus this one to give me that one. Don't do that. Y is the first one you solve for, the first law of signs you do. Those are supplementary because it's the law of signs that has the two places that are supplementary to each other. Okay, I bet you can find side Z all by yourself. Go for it. Okay, so it'd be sine of, we got to use something we know, 27 over 4 equals sine of 118, especially if that's already in your calculator. Cross products. Anybody got me little z on one of them yet? 7.749. Everybody agree? 7.749. Now, if you're handy dandy with your calculator, if you push second enter a couple of times, you'll go back to this equation, and all you're going to have to do is change your 118 to 7.575, and you won't have as much calculator to push, but that's up to you. So sine 27 over 4 equals sine, what am I looking for? 7.5. I'm going to let you do that on your own. When somebody knows it, let me know. Should be pretty short, 1 point something probably. Do you have it? What'd you get? 1.189, anybody agree? 1.161. 1.161. They're not that, what did everybody else get? What'd you get? Okay, that's 1.1. Well, everybody got 1.1. Everybody's would round to 1.2. I'm happy. If yours would round, everybody's would round to the same tenths place. I'm okay. It goes from stored values or not, and it gets that far off. So try to store or use second answer as much as you can. 1.161 is what I'm going to write down. Hey, I bet we can check it. Watch this. You need to pay attention to this because you are going to use the Geometry Sketchpad program that I'm using right now. Okay? And watch real quick. What was the angle that we were given? Watch what I just did. I double clicked right here. Our angle was what, 27? Is that right? What was our side across from our given angle? Notice that was A, so big A is 4. They're not going to be labeled X and Y and Z for you. And this other given side was 5, okay? Now watch what you'll do when you use this yourself. After you plug those in, you'll push Show Measurement. They got 1.162, where we got 1.161. 7.749, was that right? 118.425 for the first triangle for B. The second triangle for B is 7.575. Yep, we got all these. So you'll use that yourself, okay? Now, I want to show you one thing. Mr. McGann's room, and I'm not sure about Mr. Hendricks, but your friends from Mr. McGann, if you ever study with them, he does not allow them to use law signs on ambiguous cases. So I just want to show you something. Why is law of cosine safer? Can anybody tell me why law of cosine is safer? Let's go back to this. Where is cosine 1/2? Quadrant 1 and, okay, that's good enough. It's quadrant 1 and 4, isn't it? Quadrant 1 and quadrant 4. What are the degrees in quadrant 4? Something between 270 and 360, right? I'm going to talk degrees. I'm going to talk degrees since we're using triangles. Are any of those, you know, the other angle that the calculator is going to give you the quadrant 1 acute angle. Is the law of cosine, is the other angle ever going to be part of a triangle? No. So cosine's a safer bet. It won't ever trick you by only giving you one angle. It will always go straight to the right angle. But watch what has to happen. I'm going to take the same question and show you how his kids, and you are welcome to do it. You are welcome to do it. But this is what his kids would have to do. They would do law of cosine, so they'd have to start with the 4 because that's the side they know, and they would have to end with the cosine of 27, right? And in between there we have y, which would be 5 squared, plus, we'd be looking for z squared, right? Minus 2 times 5 times z cosine 27. Now, let me see your perfect math skills. How do we solve for z? Right? Oh, this is a z, isn't it? Sorry. Okay, somebody put that in the calculator. 2 times 5 times cosine 27. That's part of the formula. Remember, law of cosine has a 2 for part of the formula? 8.91. That's okay. Minus 8 point what? 91, and then I'd put the z on the back. How do I solve that? What kind of equation is it? Is it linear? It's quadratic. How do we solve quadratic equations? Very carefully. What's 25 take away 16? Isn't that 9? Okay. Did I do that right? Putting that 9 at the end. What's up now? What are y'all telling? Do you know what multiplies to be 9 that adds to be 8.91? We could factor it. We don't know that. What do? Quadratic formula. Or we could put it into y equals. Actually, we could put it into y equals and find where the roots are, where they intersect. Pass, right? That's what he does. Now think about this. If you do this in the quadratic formula or in graphing, if you graph it, you'd get a parabola and you'd look for your zeros, right? See how you'd get 2 of them? You would get, when you did that, you would get this and this z, right? Oh, no, I was at the sides. It would be the sides. I would get that side and that side. And from there, I could then finish, okay? So if you want to do that, you are welcome to. It is safer. It will always let you know exactly if you have 1, 2, or no triangles. Oh my goodness, it's begging me to restart. But that's not the way I teach it because I think y'all are okay to do it without. Now let's look. We're about to do example 2. Did I already tell you to mark off 8, 9, and 10? Okay. 8, 9, and 10 you don't have to do, but what you do have to do is ignore the directions about which side to find and find the whole triangle. Now, let's look at, real quick, example 2, which we're about to do, but let's look at it first. Okay, we're given measure of angle x, which is 13. Which is the side across from that? How long is the side across from? It's 12. Now compare the 12 to the 15. Is 12 longer or shorter than 15? Shorter. When that side across is shorter, that's when I'm going to have 2 triangles most likely. Okay? Let's go. Let's look at number 1. Everybody decide in their head whether you think there's 1 or 2 triangles. Look at B. The side across from B is, I think it's 2. Why? Because look at the side across from the given angle. So the given angle is B. So the side across from it is B, which is 3. Do you guys see how 3 is smaller than 4? That's when there's 2. Look at number 3. Look at number 3. What angle are you given? You're given angle B. The side across from it is 5. Is that longer or shorter than 4? Longer. Therefore, it would make 1 triangle. Okay? So, everybody, try example 2 by yourself. I'll roam around and get help. Example 2. We already know it's going to make 2 triangles, so get started. Okay, here's the answers if you didn't get them to example 2, which turns out is also number 2. And here's the work.